Chapter 17, Free Energy and Thermodynamics. So we're going to learn a couple things. One of them is you can't win. So we're going to be talking about energy in this chapter, and energy transactions are a little bit like gambling. I don't know if I've used this analogy with you, but I use it in my other classes. We can remember a lot of relationships by thinking of money as being like energy. And when energy leaves the system, that's exothermic, and that has a negative sign. When money leaves my wallet, that's a negative experience for me. And so money and energy. So this ties right in with that. Energy transactions are like gambling. Can you really win at gambling long term? No, you can't. 20 bucks says he can. That's awesome. I don't gamble. It's against my religion. It's also against my personality. I'd rather just hold my money. So first law of thermodynamics you learned about in Chem 1A. Energy is conserved in chemical processes. So energy cannot be created or destroyed in chemical processes. But let's think about a process that you all probably use to get here. Burning gasoline to make your car go, right? So you burn the gasoline and it gives off energy. About 20% of that energy goes towards actually moving the car, and the rest of it is dissipated as heat. Because what happens to your engine after it's been running for a little while? It gets hot. And that's all energy that's coming from the burning of the gasoline, but not being used to move your car. So it's not really very efficient. So first law of thermodynamics says the energy from the reaction, the combustion of the gasoline, will equal the energy that goes towards moving the car plus heat energy, and energy is conserved. And so the lesson from the first law of thermodynamics is you can't win. Meaning you cannot create energy that was not there to begin with. It's just not possible. So you can't win. But you can't even break even. So this is really the kind of depressing part. This has to do with the second law of thermodynamics, which I have to tell you a few things before we can even talk about that. So it's coming soon. But let's think about this. Rechargeable batteries. So let's think about a rechargeable battery. It's all charged up, and we hook it up to some device, and it does 100 kilojoules of work. And then we go to charge the battery back up. It will take more than 100 kilojoules to charge the battery. I think everybody recognizes it's going to take at least 100 kilojoules, but it's actually going to take more. And that is not because energy is being destroyed. It's not being destroyed in the discharging, recharging cycle. But some energy is lost to the surroundings in order for that process to occur at all. And so one way that scientists talk about this is we say nature imposes a heat tax. Because every time money changes hands, you buy something, you sell something, you earn money, you pay someone who's your employee. What does the government do? They take a cut, right? It's called taxes. In energy transactions, there's what's called a heat tax. So there's the heat tax, and then there's also additional energy that is lost as heat because real-world processes are less than 100% efficient. Most of them are far less than 100% efficient. But even if you could devise a 100% efficient process, in every transaction of energy, there would be a loss. So a basic principle here is fewer transactions equals more efficient energy use. The bottom line is you can't even break even. So you can't create energy that wasn't there before, but you can't even just maintain the energy that you have. So here's some pictures from your textbook. illustrating difference in efficiency between heating your home with natural gas versus heating with electricity. And this has to do with the number of transactions. If we think about burning natural gas, you burn the natural gas, that generates the heat directly. It gets blown around your house. So you lose a little bit of energy from the heat tax, but there's just the one time you have to pay the heat tax. If you're using electricity, it's going to depend on the source of electricity, but a typical source is burning fossil fuels like coal. So you burn the fossil fuel, that generates energy. There's a conversion of energy here, so there's heat tax. You made steam. The steam is used to generate electricity. There goes another heat tax. The electricity needs to be transmitted to your house. There's another heat tax. The electricity gets to your house, and then it's used to energize the heater. Another transaction, another heat tax. And then the heater generates heat, and you've lost another heat tax. So just by sheer number of transactions, heating with electricity is less efficient than heating with natural gas. Anybody have any questions? Yes?
With this heat tax or how heat released,
Mm-hmm.
how does salary work then?
You're saying my analogy isn't perfect?
No, I'm just asking, how would
Okay.
salary work?
So how would salary work in there? Well, see, when okay, so this is you going to the farmer's market and buying food directly from a farmer. And depending on his situation, he may be required to collect sales tax. And so there's that tax right there. This would be more analogous to, there's this big corporate farm that's growing the vegetables, and they sell it to someone who processes it. And the processor then has to pay someone to ship it and pay someone to distribute it and put it in the grocery store, and then you buy it. And there could be taxes or losses of some sort all along the way. If it's not actually taxed to the government, there's a cut to each middleman, right? The distributor isn't going to do it for free. And that all gets added up into the cost of your fruits and vegetables. Does that work for you?
Yeah.
Yeah?
I'm actually asking, like, since salary says that there's zero calories, how would...
You talking salary or celery?
Celery, sorry.
Oh, celery. I thought you were talking about salary. Celery, C-E-L.
Since there's no calories, supposedly no calories, and it takes more to actually to break it down than actually gives off.
There are it's just you're in a deficit because you have to spend calories to break it down, to reduce the stuff that breaks it down.
Yeah, what he said. Celery does have calories, but your body has to expend energy to chew the food and swallow it, and then also to digest it. And the return on that is not positive.
Yeah.
And so then my question is, why eat celery?
Yeah.
I don't think it even tastes good. So, any other questions?